Feel free to ask as many questions as you want. With that, let me quickly share my screen and let's get started. As I said, the hands-on lab will be starting shortly. This Discover AI is a part of a series that we are doing at Snowflake. We've already done Discover in February, where we talked about some data engineering principles. We talked about data management, data governance. And this module is all about discovering AI. We will conclude this towards the end of this year with Build 2024, where we will talk all things application. So you see, it's a logical progression. You go from data to AI to applications, and this is how you really make your AI stand out through applications. This is how you let your AI speak to your stakeholders, to your business, to even yourself. So stay tuned with us. We have an action-packed agenda, as I said. We have been doing this for quite some time. In February, we did your data foundation. We are at enterprise AI right now, and we'll talk about how Snowflake makes AI more easy, efficient, and trusted. We'll be concluding this with Build in towards the end of this year. We'll talk building and distributing applications on Snowflake. So if you're joining us from India, then we'll be doing Build in some of the cities that you're very well familiar with, the likes of Bengaluru and Pune and maybe even Hyderabad. That said, we are also present across multiple cities, and I'll walk you through what we are doing in India and also in the region very, very shortly. But this is your journey, and we are discovering AI. Now, this is very, very important. For those of you who are joining Discover for the very first time, you don't know what Discover is all about. This is a live event. This is a live event. I can wave my hands at you and tell you that this is not scripted. We will follow up with more content at Snowflake World Tour. So if you are in APJ or if you're in India, you can go through our Snowflake World Tour website. I'll bring the QR code very, very shortly. And you can see where we are doing our World Tour near to you. And you can join us for a live session there in person. We will highly encourage all of you to use the Zoom Q&A feature. We have a lot of experts on hand. They would love to answer your questions. So any question is a good question. If you are facing troubles with how do I set up my account, versus if you have a question with, hey, how do I fine-tune my LLM model, everything is fine. Everything is absolutely okay. So make sure that you use the Zoom Q&A feature. It should be on the top of your screen or at the bottom of your screen and ask questions. It's not too late to invite your friends and colleagues to Discover. This is an absolutely free event, free enablement. We are going live with so many exciting announcements. This is an opportunity for your friends and colleagues to learn more about Snowflake. We would also encourage you to check out our summit keynotes. For those of you who are not familiar with what Snowflake Summit is, it is our flagship event that we just concluded in June. We had lots of sessions there. We had some luminary speakers. Some of them you would already know, the likes of Andrew Ng, the founder of the deep learning.ai course on Coursera, and also the founder of landing.ai. We'll talk more about it, but once again, if you want to know what we did at Summit, the QR code is right here at the bottom right-hand side of your screen. Take a quick screenshot. You can scan it later. And we'll also pop in the link for you in the resources pane, so you don't have to worry about it. Now, that said, let me tell you what the agenda looks like for today, tomorrow, day after, and the day after tomorrow. Today, we are doing a virtual hands-on lab. It's an introduction to machine learning with Snowpark ML. You'll learn all things feature engineering, Snowflake notebooks, doing machine learning with Snowflake. It's hands-on. So if you want to follow the steps with us, now is the time. Set up your laptops. Again, grab yourselves a cup of coffee because it's going to get really interesting. Tomorrow, we are going to talk about some of the highlights from the Data Cloud Summit and also talk about the data and AI innovations we have already brought in. And we are announcing them day in and day out. You would see this on our Snowflake handle as well. We are going with, so this is the year of GA. We are calling it All Things GA this year. We'll talk about data science. We'll talk about MLOps. I know a lot of you have been asking about MLOps with Snowflake. And then we'll go into the likes of Git integration, RAG-based chatbot, and we'll go into a feature store because why not? Let's make data science more easy, accessible, reproducible, and reusable. And finally, on 19th, we will conclude with the virtual hands-on lab. This is a bootcamp, a generative AI bootcamp, which I will highly recommend all of you to join. But this is the journey. We don't want to overwhelm you, but we also want to make sure that you get all the information that you need about Snowflake AI. Now, that said, let me quickly tell you what we have been up to and the kind of effort and the time and the resources that we have been investing in making sure that we enable you as a developer, as a builder on Snowflake. We have 50 plus quick starts. You can navigate all of these quick starts on quickstarts.snowflake.com. Again, the resources will be shared with you in the resources pane. We have more than 25 courses, parts on Snowflake University. We have SnowPro certifications, of course, for those of you are really serious about it. And I know there are a lot of you in India who are already certified. You can mentor so many individuals who would want to get themselves certified. So make sure that you get yourself certified with Snowflake. We are present in 7 cities in India. So we are there in Delhi, Bengaluru, Mumbai, Jaipur, Chennai, Hyderabad. If you want to join us in any of these cities, we meet quite often. So make sure that you join our user groups in India. We'll again share that link with you. We also do Snowflake Ascent. I'll share the link with you very shortly. What Snowflake Ascent is all about. It's a free education exercise that we do. You walk away with a hands-on fundamentals badge. And that is something that you can brag on with your friends and colleagues once again. And we are doing Snowflake Discover, again, absolutely free of cost. We are there to educate you and enable you to learn more about Snowflake. As I said, we'll be doing Snowflake World Tour across many regions and multiple cities. If you're joining us from APJ, you can scan in this QR code and find the city closest to you where we will be doing a world tour. If you are joining us from India, then we are going to be doing the world tour in Delhi, Bengaluru, and Mumbai. Delhi is on 30th of August, 19th of September is Bengaluru, and 4th of October is Mumbai. So if you're joining us from any of these regions, or if you find the city is quite close to you, please come meet us. We will have a lot of fun. Now, that said, let me bring up on stage my dear friend and colleague, Kamesh, who is our lead developer advocate. He is absolutely brilliant. So let me tell you something about Kamesh. One, he knows Snowflake inside out, and he's a great educator. And one more thing that I'd love to tell all of you is that you will see a stark difference between the profile picture here and Kamesh right here. Kamesh, let's just wave our hands and prove to everyone that we are
yeah, it's me again. Thanks for
yeah. So I could not recognize Kamesh, and I think now I'm inspired. I should take off my beard as well and look maybe I don't know 15 years younger. Yeah,
yeah,
that's the intention. Super. So with that, I will hand it off to Kamesh. But once again, let me tell you what Ascent is. We are doing Ascent again, free education exercise. You walk away with a hands-on badge. This is some pure bragging rights that you get. If you're joining us from ANZ, once again, we are doing this on 29th of July. And if you're joining us from Asia, it's 30th of July. Scan in the QR code, just take a screenshot, or we will pop in a link in the resources pane. With that said, we'll hopefully see you at Snowflake World Tour. I will hand it off to Kamesh, whom I could barely recognize. And we'll get started with the hands-on lab. Yeah?
Yeah, thank you so much, Farhan, and thanks for the compliments. And hello, everyone. Good morning from India. So let me take a quick second to start sharing my screen, and then we get started with that. Okay, I hope everyone could see my screen all well, clean, and my voice heard. In case of any drops in my voice or anything, please do let me know so that like I can adjust my mic or anything. Obviously, these are all tech stuff. So as Farhan introduced, so what are we going to see today is absolutely an introduction. I should call this as level 100 kind of a thing, where we are going to see about an introduction into machine learning with Snowpark ML, and we're going to see what is Snowpark ML and et cetera, et cetera. So just a little bit of logistics before we go further into this. In case, at the interest of time, you can just keep popping your questions on the Q&A. We have a great experts going to answer your questions live when I'm doing the session. And in case if you want to continue this conversation, even after the session, I have my socials QR right there. You can take a snap of it and get me connected on LinkedIn, GitHub, Twitter, wherever you wish. And I'm happy to take the conversation up further as well. And we have a rich set of resources on our resources link that is going to help you to follow with me in case if you're following the hands-on lab that will be starting soon. And then we are also have put few more other links for all the other events across. So I'm just putting a screenshot. Maybe the screenshot will be a little different when you see it, but where you have to go find this is all go to your Zoom thing, and then you go have a resources section. You could see the bunch of links there. So we just started a discourse community forum as well in case if you want to continue conversation there. We are most welcome to do, and there'll be a lot of experts answering your question. All right. With that, let's jump into the agenda for today. So obviously, we had the introductions done. So what you're going to see is like, we are going to, as I said, it's going to be a level 100 kind of thing, right? So we are going to see what is Snowflake's architecture, just for the context sake. And then we are going to see how Snowpark, we'll say what is Snowpark and how it fits into the architecture. We see the APIs that Snowpark offers you, which helps you to do build apps, do all of this stuff, including ML. That's we are going to see later. And finally, we are going to conclude that with a hands-on, where we are going to say we are going to do a simple prediction using our Snowpark ML API. And after that, we still have time. We can take QA, question and answers. As I said earlier, you could definitely keep popping your questions on the chat, on the Q&A, and we have experts answering your questions. All right. Before we get further down, so we're going to give you a 30-day free $400 worth of credits, Snowflake credits. You can scan the the QR code. We have the link also on the resources. And your one important thing about this trial is that if you're going to continue the journey of Discover until the bootcamp that we are going to do on 19th, please do make sure that when you sign up for your Snowflake account, be sure that you're choosing US West as your region and enterprise as your thing, because that's how we can do your Cortex LLM labs, which you're going to see on the bootcamp. So, which means that to make things convenient, if you already have an account, please don't worry, create a new one using the bit.ly link that we are on top. And we have also on the resources section. You can do any of these things and make sure that you are on AWS US West region, right? For all the things on all the labs and all the quick starts that we are going to share to work with. I think we already have, so the links that provide on the resources will make you create your account on this thing, okay? On this particular region, on this cloud provider. So I'm just calling it again. Make sure that you're on US West, AWS Enterprise Edition. You obviously get the same credits, but you'll be able to try the LLM features that we are going to talk about. All right. Still, if you have questions, obviously you can just pop it on the chat, and then we have the experts answering your questions again. Great. So as I said earlier, so let's talk about how, before we even get into Snowpark and before you even get into ML. So I just want to give a quick context of people new to Snowflake on what Snowflake architecture looks like, right? So this is our platform architecture as you see. And we have the core, like if you can imagine like your Earth's core, right? So which is very important for all the resources that we have. That's we call as a core of our thing is the storage, right? Where you store all your data, definitely a warehouse. It definitely needs some data to be stored, and we have separated that from our compute. That's what you see on those two circles that you see on my screen. The internal one where you can store your structured, semi-structured, unstructured data. And the whole idea, and then we have an elastic multi-cloud that sits on top of it, kind of like giving you runtimes. You'll be seeing about these runtimes like Python, SQL, Java, and Scala. It's elastic means that it's scalable. We'll see the different sizes as well. Once you go further in the slides, I'll talk about what all those things has. But the whole idea here is that these two things, your storage and your compute, are separated. That's one of the I should call the uniqueness of our architecture, because that helps us to scale stuff independently of each other, right? Because once you start developing your applications, once you start developing your apps or ML or whatever it is, so you want things to scale independently, because not that compute is a bottleneck to storage or storage is a bottleneck to compute. That's one of the things. These two things will help you to do your cloud services better, right? So we have everything on cloud. As you know, we are AI data cloud. So we have everything on cloud. Separating this on the architecture side helps us to provide even better services and helps you to build application that's going to be, super fast performing as you expect, right? And we can also add the other things like your governance, which is a very core thing. And we also collect metadata. It's not just collect metadata for the sake of collecting it, but we use it inside our services as well to do your performance optimization, sharing and collaboration. All the services that we provide sit on top of these two elastic cluster compute and optimized storage. So we'll see a few of those things when you do the hands-on lab, but the idea is that we scale them independently so that you achieve the optimization and performance that you want to do. And on top of that, we have the Snow Grid that allows you to connect multi-cloud. So what I mean by that is, so when I want to deploy a thing on AWS and I have my storage on, let's say, in Azure, then these kind of Snow Grid cross-cloud and global thing helps you to kind of talk with each other without you going across, right? For example, this is what we call, because nowadays people initially started with just one cloud, just AWS alone, or just Azure alone, or just the other one alone.
Ramesh,
But now,
sorry for interrupting. I think for a lot of users, the screen is frozen. Can you take it off and bring it up once again?
It's frozen? Okay, let me do
Yeah.
that. Sorry about that. Just go to do, share again. Is it up again?
Yep. Can we try going back up? Yeah. Okay.
Yeah.
Now it's
So
I hope for everyone the slides are refreshing. Super.
yeah, sorry about that. I think the technical glitches. Thanks for calling out. Thanks so much. I think sorry. I think let me refresh it again. So just a quick overview about the architecture. So we have the elastic multi-cluster compute, as I was talking to you about. I think the optimized storage, which is a central thing where we store all our data files, all our files, etc., etc. Then we have the multi-cloud compute, which is again, end of the day, it's a compute. In Snowflake world, when you talk about warehouse, it's not a physical warehouse, it's a compute backed by storage. So that's what we call this as. And we have our services sitting on top of it, like whatever services you avail, like ML is one thing which you're going to see now. So those all sit on top of this, and they leverage this elastic multi-cluster compute and optimized storage. So this is very important because that's how we at Snowflake achieve the performance we are giving to you, right? The better performance for your thing, and you can scale your cloud, you can scale your compute, you can scale your storage independently of each other, right? And the last point I was mentioning about is that, so when people go for cloud architectures, right? Earlier, they started with one architecture, just AWS or Azure or GCP, or you name the cloud. But nowadays, people have started to have multi-cloud and hybrid cloud architectures. So when I say about multi-cloud, I have AWS, Azure, GCP, everything has its own services running inside an organization. When you talk about hybrid cloud, this goes even a step further, that you have your own data center also runs on top of this, right? Which is coming the hybrid cloud architecture. So we support the multi-cloud thing by using SnowGrid, meaning to say, like, I can pick, let's say, S3 from AWS. I can pick the Azure for compute, for example. I'm just saying for an example. And then we can combine these two things, talk with each other without your service getting disturbed. So that is, again, a very cool feature that Snowflake offers you. So we can read more about our architecture and each individual components on our website, docs.snowflake.com, which gives you more details about it. Okay, but I just want to set these things up, right? Great. So when I talk about architecture, so when you talk about architecture, so one of the things that always sits on top of, even my architecture is elastic, even my architecture is compute is elasticity, and then it computes, grades, I mean, kind of like expands independently and all these things. You have the best in class of architecture. But one thing which goes very important is that when I start building my applications, I want something which sits on this architecture and kind of more cohesively. I mean to say, like, it works well with architecture, it scales well with architecture and all of the stuff. That's where Snowpark comes into picture. So what we call a Snowpark is nothing but a set of runtimes and libraries, right? That we have defined so that you can start your applications, build an application using Snowflake and make your application interact with other stuff, right? So that's what we call as at Snowflake. We call them as Snowpark. And what is Snowpark? As I said, set of runtimes and libraries. So what are these libraries are? So libraries are nothing but your SDKs and APIs and other stuff that you use to build application. That's what we call as your data pipelines, your applications. We call something called as native apps and all these things. That's going to be a Snowpark API to build a very basic data application. Obviously, Streamlit coming into the picture. And we call them as libraries because you can use any ID you want and then do, for example, if you're a Python developer, obviously data scientist, data ML enthusiast, everybody's going to be mostly around Python. You can just do pip install of your application right on top of that. So that helps you to kind of do this application, have a consistent thing. We see more about how you achieve this consistency down the lane. And also on today's subject, right, we also have the Snowpark ML features added into Snowpark. You will be wondering, okay, I have scikit-learn, I have XGBoost, I have all this light BGM open source library. So what does Snowpark does extra, right? We're going to see more, but I'll just give you a gist of it. So what is, for example, like I'm coming from a open source background. So we have a lot of open source projects run. For example, let's take an example of a Java thing. If everybody knows about it on JBoss or Tomcat or all these servers. So what companies like, for example, Red Hat or other companies like your Pivotal or all these people does is they take the open source code, harden it out, and do a quality testing and make sure that it works for you in an enterprise organization, because that's very important. Because open source is great, wonderful, but when I take to my production related thing, right, I want it to be hardened enough, right? That's exactly what we also did. We also took all these scikit-learn and gradient boost and all these kind of libraries and then put them inside Snowpark and make it available as part of our ML Snowpark ML thing, so that like you can go to Snowflake for any kind of production issues or CVEs or whatever that comes up on all those libraries down the lane, because that's very important when you deploy something on production. So that's one thing. The second one is also like we want to make it scale distributed, right? Because we talk about scale, we talk about performance, and we want to still, okay, we want to make sure that the application scales across, right? It's in the distributed fashion. Again, we added the distributed thing that we always known for at Snowflake, because we do distributed SQL execution, distributed code execution, distributed Python execution, etc., etc. So we added those things also on top of this so that these ML libraries work perfectly well, even in a distributed environment. With those two things given, those are the higher level things. When you come a little bit lower, where the code actually gets executed, where we want more sandbox kind of an environment for Python, Java, or multi-language thing, that's where we have those virtual warehouses. We'll see when you do the hands-on lab, we'll see how we create the virtual warehouses. It's nothing but it's a computer that's going to run your queries or run your ML models, etc., etc. And Snowpark Container Services goes a little bit one step further. We need to say like, okay, hey, I want to do, because I'm going to do ML, so I want to have GPU support of it, apart from CPU support. Then what do? I go for Snowpark Container Services that gives you those GPU support as well. Okay. So that's in a crux. If I can summarize what Snowpark gives you a language of choice in a single platform on Snowflake. I can use Java, Python, Scala. You want to execute. Even we have SDKs for all common languages. You can pick up those SDKs and work. And then we have scalability without complexity, right? The architecture that we did, I showed you earlier in a couple of slides earlier, that allows you to execute these things really, really well. That's one of the things that you also have this thing about the complexity of it. And then you also have no governance, no trade-offs, right? Because most of the times when you go out multi-cloud and other stuff, people say, hey, I have a trade-off, like because you have to do this trade-off because you want to do this. But we say there's no worry about security trade-offs. We make sure that your code is secure, your data is secured when it's inside our environment. Okay, great. So just to give a little bit overview, a little bit more about Snowpark, like what did I do with Snowpark if Snowpark is not getting executed inside, right? What is with Snowpark and without Snowpark kind of stuff, right? So when we say without Snowpark, so the screen on my left shows you like without Snowpark, because I have to take data out, talk to Snowflake, move data in, and I have to do a network traffic that is involved in between. That could be latency within applications. And you need to have multiple processing engines, which will also add to your learning cost, your TCO, etc., right? So when we talk about Snowpark, is everything is going to be executed within the sandbox that Snowflake gives you within your account, which means that data is not moving out, which means that the performance is going to be a way higher than your data moving in and out over the network thing. And also it's secured, and we have the governance and ACLs, everything applied so that you can make sure that your data is not leaked or kind of compromised or etc., etc. And we also leverage the other ones like your data pipelines, AI, ML models, and apps. More than all, the infrastructure, the right infrastructure that is required for you to run these ones perfectly. Okay, we'll see about that in a second, again, as I said, on the hands-on lab. But that's the advantage that you get with Snowpark, right? And without Snowpark. But you'll be wondering, why did I ever start with something like a Snowpark as well, right? We'll talk about a little bit here, right? So what is Snowpark? Why the name is Snowpark, right? Like, so for example, like we still adhere to the data frame semantics and syntax that we came from Spark, right? Because Spark was de facto thing that goes into when you're starting to do data engineering or building data applications and all these things, right? It has been there for quite a long time. But if you think for a second, Spark has its own limitations, right? Because though it is wonderful doing stuff with data frame syntax, which is fine, but it doesn't give you distributed stuff. It's hard to make a distributed stuff, obviously running with a Java background and coming from a deep Java experience. I know how hard it to make something run on a cloud, with a Java-based thing, right? Because we need to do performance tuning, there's a big learning curve and all these stuff. And what we try to do is like we picked up the same data frame syntax so that like people are moving from Spark to Snowflake, which is Snowpark, just to give the name combination. Like when you move here, so it allows you to follow the same syntax without changing anything. But we take out other stuff like for example, executing something on distributed stuff using our own API thing, the Snowpark API, right? And the data frame API again, here what we put is again, you can use the same data frame syntax, whatever you're used to writing your queries. And internally, we transpile the thing using a query translators into the SQL queries. And again, these SQL queries are lazily executed unless and until you query for the data or you want to show the data using data frame.show kind of thing. That's where the actual query gets executed. Until then, these are just queries sitting inside. Like we compute. I'll show you an example when I write some queries down the lane. And also, it gives you an ability to write your own Python functions using different libraries. We'll see in a second like how we can bring multiple different libraries into Snowflake, which we call as user-defined functions and user-defined table functions. We give all these things, stored procedures. For example, we are writing here one thing like a detect fraud thing, which we are writing here. And these can be run as a stored procedures behind the scene, Python stored procedures end of the day inside Snowflake. And we can use this combination to call these stored procedures within your SQL as well. So you get a rich set of flexibility and also something which you're used to this when you're going to go with Snowpark, right? And again, when you're migrating stuff from Spark into Snowflake, it makes things easier because you're familiar with the syntax of the data frame thing that brings you in, and then you can start doing the same thing using the same kind of data frame syntax and APIs to kind of do the work. Okay. So what else we had on top of this? So we just recently launched like public preview of Snowpark Pandas API. So what is this about? So because Pandas is always single threaded, right? Because I cannot do distributed computing with Pandas. So what we made sure is that using an open source project called as Modern, probably I'll drop the link on the resources link. There is something called as open source project called as Modern, which Snowflake engineers are involved in. So that helps you to execute Pandas API in a distributed way, which means that you can do parallel processing of data. You can properly process a huge amount of data in one single set without compromising your performance. So I think I don't have this hands-on. We're not going to cover this, but we have the links on the resources. Probably you can just go check it out to see what Snowflake Pandas API does, which allows even more, a little bit further than your syntax. Right? As you show the differentiation here, so it extends Snowpark, which means that the same data frames API, the same data frame syntax, but we use Pandas underneath because something which most of the data engineers are familiar with doing the stuff, right? So, and gives you their distributed capabilities on our Panda, right? Which means that you can distribute the transactions across multiple different nodes or multiple different computes so that it gets faster. It's done faster. Okay, great. So what does Snowpark gives you? Snowpark also gives you what is called as a dynamic file access, which means that, see, whatever we store, and because at the end of the day, if you go to the storage or Snowflake or any other data warehouse, like you are going to store structured, unstructured, semi-structured data, and that is going to reside inside, and we are going to make sure that they are encrypted so that it's not accessed by any people without proper authorizations and authentication, right? And to an extent, when you want to access those kind of encrypted data within an API, so what basically happens is that I need to do a lot of boilerplate code, right? It's basically, okay, I have to take the keys, I have to decrypt this, read it, encrypt it again, and put it back something, making sure that there is no leak everywhere. So with dynamic file access within a Snowpark API, what we have made sure is that we have taken out all those boilerplate code out of you. If you have the right credentials, we take care of doing all those encryption, decryption for you, and take the data, read the data out, use it within your UDFs, UDTFs, and store procedures or SQL commands or wherever you want, and then without compromising on security or governance. Okay, that's what dynamic file access does for you, right? It's again a set of file APIs that you can find within Snowpark that helps you to do this stuff. All right. Again, multiple Python versions. This becomes another important feature that we want to do. Obviously, most of the people who use Python on cloud, we want to give you multiple different versions, though that you have the backward compatibility, forward compatibility. You can do testing with the new APIs to see everything works perfectly fine. So these are all done from within your sandbox. As I told you, I'm going to show you again on hands-on right within the Snowflake console. Right? So you're not going to go out anywhere beyond this. And also, we also provide you Python task APIs, which allows you to do the DAGs, and then which you can schedule the task, we can use in combination with our streams and tasks so that everything that you run or are scheduled, run, and running in a cron job kind of a fashion, for example, to do everything, right? This also helps you to do the Python-based workflows instead of SQL-based workflows. So if you think for a second, everything is in Snowpark, we all do Python, right? Just if you're familiar with Python, if you're good with Python, then do everything with Python, and we'll take care of converting everything to what are the SQL equivalents of it, right? Awesome. So how do we bring these libraries? We talked about, okay, I can bring in my own libraries. I can do all the stuff from within writing UDFs and every stuff. But how do we actually bring these ones inside? So that's exactly what we are tied up with Anaconda. And then we have the Anaconda packages installed. We'll be doing that again on our hands-on lab to see how we can draw packages, which is secured. And we don't blanket get everything within Anaconda. We have a dedicated Snowflake channel from where you can install these things. So even if you're running something locally using your Panda package manager, you can point it to Snowflake channel and install all these packages so that even if you get to Snowflake, it's going to use the same package, same version, everything, which is more secured. We do all the license checks and everything before the package actually lands in Snowflake Anaconda channel. Okay. So you'll see more about that when we do a hands-on lab. I'll show you how do you pick up the package and install it. Okay, great. So we do this, but what if I want to add my custom package into Anaconda, Snowflake's Anaconda? There's a process that we actually do that. So we can put a request for that, go to report.anaconda.com, packages, community ideas, drop in the package name that you want to do. So we will do all the review with Snowflake plus Anaconda. I'll do the review to make sure that library is okay to be added there or used. And once we are okay with that, that's going to land up in the Snowflake releases that's going to happen, right? We already have lots of other stuff actually listed below. Is already there, right, available for you within our Snowflake Anaconda channel. Okay, so this gives you an overview from an API point of view, right? And then what about machine learning? That's the subject for today, right? So what we do with this? So in Snowflake world, we kind of categorize our machine learning or LLM, Gen AI into three different buckets, basically. So what are these buckets? We classify them based on seconds, minutes, and hours. So what does it mean exactly, right? So imagine like I want to create three different personas here. Like the first persona is somebody, for example, like me who doesn't know anything about ML. And then it's going to come down and say, hey, I want to do anomaly detection or I want to do forecasting, right? So what do you have installed? So I don't want to write any kind of a Python code or anything like that for me to do this stuff. Then what I go straight out is I go to Snowflake ML functions. We already have out of the box like 5-6 functions that's available for us, like forecasting, classification, and anomaly detection, and all these things available with XGBoost model that we used. And they're readily available to be used either as a Python API or I can use even them in SQL. So which means that in seconds, I'm going to get the data which is there within Snowflake. I'm going to apply these functions on top of it and then going to run it. Even if it's not within Snowflake, you can use the standard injection mechanisms to bring the data into Snowflake and apply Snowflake ML functions. So that is the very, I could call get started impatient, and I don't have skill sets, I don't have resources, but I want to quickly do test something. So that's something I want to build later. So that's the first piece. Okay, that's what we call as in seconds. So what does in minutes do, right? So that's exactly what you're going to do on hands-on lab, because people like you who are already aware of something about ML and you want to find the right tools to do the job, right? For example, I'm going to use Snowflake notebooks to kind of go execute all my ML, all the code that I'm going to have. I'm going to use Snowpark ML modeling APIs. I said earlier, it has the scikit-learn, XGBoost, LightBGM, everything embedded inside that. We're just going to call these out, everything done. That's morely around production side of it. The moment I cross production, I want to deploy it into, cross development and deploy into production, then that's where I'm going to use the model registry and feature stores, which means that I can version each of the models. Obviously, the models are iterative process. We keep improving it. So we can version like your code and put it inside Snowflake model registry and pull it out whenever you want to test it. The similar thing with the feature store as well. These two things are good. End of the day, it's going to land when somebody's consumption, right? Your consumers, maybe your clients, your customers, or people, public, we are going to use it. That's where Streamlit comes into the picture. So that's where you're going to say, hey, I'm going to deploy the Streamlit application there and then access these things which is deployed, for example, using Snowpark container services, and then kind of query this data and then run my predictions or whatever you want to do. So that's going to be in minutes kind of thing, right? Which is where the idea is like, okay, I have a bunch of skilled people, like the people who are sitting in this particular session, and they are going to use it, and then they are going to build the application, they're going to deploy it. And the last one is going to be the most advanced use case where I want to bring in the externally trained models. I get it inside this, and then I want to have more compute, right? One of the biggest hiccups with machine learning, again, think that's observed my personal opinion is, what is the right infrastructure that I can use to get the right performance I want to get these models trained and these models deployed? Okay, that's exactly what we're going to do in the other section, right? Where we can take the models, get in the models, use the Snowpark container services to run your own GPU-based computes, or warehouses, what we call as, and then run your GPU-based inferences on top of them, right? Which gives you the right prediction or right performance or right training things that you require to do this job. That's going to be the other thing. That's more the advanced use cases, right? And one thing you note about even the machine learning, all these things sit on a common Snowflake governed data, which means that the security, the hardening and everything, the ACL, everything is there. You're not compromising on any of those things. That's what we said earlier. There is no governance or security trade-offs, even when you're doing ML, right? Even when you're doing LLM, you're going to show that in the Friday session as well. And obviously, we have the warehouses. We'll talk a little bit more in the next upcoming slides. What are the warehouses that fits here, right? Again, iterating in Snowflake world, warehouse, we call them as virtual warehouse interchangeably. The idea is that this warehouse is the compute that you run, end of the day, right? This compute that's going to use to run your queries, you run your models, etc., etc. So they're not a physical file storage, because if you see our architecture, we have separated the storage and the compute into two different things for the performance sake. Okay, that's what we have. And then for advanced users I talked about, okay, that's exactly the one which I highlighted right now is going to be the part of the hands-on lab, where for the data scientist who wants to do a lot of customizations, feature transformations, and then all of the stuff, and then create the models, do the estimations, and then finally find out the best model using the estimators, and then registry to store the data is what we're going to do as part of the hands-on lab. So this is more for what I call a mid-level, kind of a people who are skilled enough in ML, but they want to know what are the tools that I can use from Snowflake to help me to do ML modeling, model registry management, and all on top of that. And again, based on the ML compute infrastructure that we are going to use to make sure that these works in the right way it needs to be run. Okay, that's exactly what Snowflake ML does. So a little bit more on ML modeling API. We'll see that again on the hands-on lab, but we already have all the pre-processing pipelines that's going to be executed in a distributed fashion. That's the thing which I want to highlight again here. It's going to be running on a distributed fashion, which makes sure that you get the adequate performance when you're training the model or getting the inferences from the model. Again, using the scikit-learn XGBoost models to do the model training. As I said, they're all wrapped inside Snowpark API, so that you just use Snowpark API for even ML models, and then use all the functions, all the classes from those respective open source libraries. Okay, and you're going to use Snowflake notebooks. I'll show you how we use Snowflake notebooks to do this job as well. Yeah, that's great. So this is Snowpark optimized warehouses. I think it's just for information's sake. You can go to the link that's right there. It's going to be a single node operations. We give enough memory for it to do all this computation that is required. We give enough cache for it to go do the job for you to do all the caching, Python libraries or Java libraries that you're going to use when you do the model training. So that's, again, we just call this a Snowpark optimized warehouses. I'll show you an example when I create one to show how we can create one Snowpark optimized house so can achieve the performance, do the stuff quickly, right? And these are the various sizes of the Snowpark optimized warehouses that we have, which helps you to do what kind of, like, let's say I want a medium-sized thing or large or Excel. We can go read more about these things on the links that we provided, docs.snowflake.com, to give you what exact compute thing. So this is more of a Snowflake size. It's nothing to do with the cloud provider. And we take care of translating these ones to the respective cloud-based compute sizes. Okay, so you don't need to worry about those things. And as I clocked it down, a single node use cases, 16x memory, then excess, right? And then for the whole multi-node use cases where you want to do parallel computing, we'll see a little bit more about that during one of our examples that we are going to run. That is going to use the larger ones, right? Snowpark optimized warehouses. So if you're not using Snowpark optimized warehouses, you're not going to achieve the distributedness of those operations. All right. That's great. This is just a summary. So with production ML made easy, in other words, we have ML development and ML ops separated, and we talked about all these things: Snowflake notebooks, modeling APIs, Snowpark pandas, And again, so how do we use streamline development using Snowpark optimized warehouses without data movement? And finally, we are going to go to the unified seamless ML ops, where you're going to see about model registry, feature store, ML lineage, etc., etc. Okay. So with that, I think probably it's a hands-on time. Let me take a quick tab on how much time we have.
Kamesh, just one quick thing. I know a lot of attendees skipped the account creation part. So if you can go through those slides once again,
Okay.
real quick, and for the benefit of everyone.
Sure. I think I can do that. Let me go back quickly. There we go. This is the QR code. Probably if you want a QR code or if you want a bit.ly link, you can go there. And at least we want to create an enterprise account as is shown here, right here. Make sure that you're an enterprise and the region, AWS West Oregon. I think these get automatically populated when you use the bit.ly link that is right there on the top, which is also there on your resources section. Because we want this. So I think ML works everywhere. But if you're going to come down again for Discover's GenAI bootcamp on Friday, then you need to be on US West because we have those services available only in select regions as of now. So, so probably make sure that you create your account here on AWS region on US West Oregon, and then choose enterprise as your Snowflake edition. So that you can test all the features on all the things that you can follow the labs that I'm going to do on Friday on even today. Like the lab should work in any account. So, but this is just for a convenience so that you don't need to create it again down below.
Okay, can we go back to the QR code once more?
Yeah,
Let's
we are there.
we are going to leave it on for a few seconds.
Sure.
Let's give it 30 seconds so that everyone can take a quick screenshot of this. For those of you who remember the steps, again, the free trial link and the Discover participant aid is in the resources pane that you'll find at the bottom of your screen. If you're not able to do that, just scan in this QR code real quick or take a quick screenshot. Just take a quick screenshot, scan it later, and create your trial account later. We'll still have a couple of minutes before we start off with the hands-on lab. I know you've been hearing all about what we are doing with Snowflake AI and machine learning. We just want to give you a breather, a minute or two, so that you can grab yourself a glass of water, a cup of coffee, and we'll get started shortly. And Kamesh, that's a cue for you as well. Let's stay hydrated. Super. I hope you're all able to scan this QR code. We will go on to the next slide. Again, remember where and what you need to click. Again, you need to fill in your details. The bit.ly link is up here. Make sure that you select the Enterprise Edition. You select AWS and you select US West Oregon for this particular hands-on lab. I hope this is very, very clear. Again, take a quick screenshot. You don't have to follow these steps as the slides say. You can take a screenshot and then in a minute or two, create your account. There will be some authentication links that might be sent to your email address. Those will also be shared for those of you who are asking questions on whether or not the session is being recorded or this recording will be shared with you or not. Yes, the session is being recorded. We'll send out a recording link to you. However, if you're joining us live, you can see Harish in the back channel. You can also see Anshul, and you can see everyone else on the back channel who is just helping you out with all of the questions. There's Sujan as well, helping you out with your questions. So make sure that you ask your questions in there. We'll take some questions live if the time permits. But now, in the interest of time, let's just quickly roll over to the hands-on section of this hands-on lab. Kamesh, over to you.
Yeah, thank you so much, Farhan, and thanks everyone. I hope you got these links created. And again, so we're going to do a quick start. The quick start link is on the chat. I'm going to run through the steps. Please don't worry if you're going to miss these steps because you can completely reproduce that because the quick start is publicly available and we have the link given to you, so that's easy for you to go back and try it by yourself. Right? There's no mandate that you have to exactly follow my steps. I'll just run through those things just for convenience to see how it works on a Snowflake console, what we call a snow site. Just give a quick introduction about what snow site as well for people who are new to Snowflake. And then you can follow it up once you're getting back after your work hours or whenever you want to try, or you can even follow it if you're if you will to do that. Okay, I'm going to stop my presentation on my screen and just going back to snow site. There'll be a flip of that while I do that. You can just make sure that your account is created as well. Okay, let me stop my share And then I'm going to go back to my browser and then go to Snowside. I'm going to share this link as well. I think the link, the get started link, I'm going to let me share my browser for the convenience so that like I can flip my browser windows. I hope like my browser is visible right now. Okay, in case if you don't see this, just call me out. I think I can reshare it again. Okay, so this is a quick start we are talking about. I think this getting started with Snowflake ML. You can go to quickstart.snowflake.com. We have this quick start link right there on the resources section. And even if you ask like our friends on the support, they can just drop this quick start link quickly for everyone as well for you to get started. So this is what we are going to follow. What I'm going to do right now is I'm just going to quickly run through all the chapters and then we'll go about doing each one separately just to give what you're going to have. This is going to take like roughly around 30 minutes. Excuse me if you go a little bit up on the time than scheduled one, but I'll try to be on time. But in case if you're going up, then please excuse me with that as well, right? There we go. So we just go to the overview here. I think most of these things we talked about just as part of the slides that we there. So I think I was technically a little bit faster because I was a little bit want to be conscious on the time so that I've covered enough part of it. And since it's being a YouTube live thing, like probably I might be getting a recording as well, and they can just see this recording coming back to our website. So I think these are all things that we covered. It gave you an overview. We're going to talk about all these things. You're going to see how these works. And we're going to use Snowflake notebooks to do this job, right? I think that's what we're going to do. You're going to use Snowflake notebooks for all the tasks that you're going to do as part of step 2, step 3, and step 4. You're going to set up a data, then going to do ML feature transformations where we're going to apply the one-hot encoder, min-max scaler, and all these stuff. And one thing I want to call out here, so this is not going to be a ML tutorial. We need to say like, teach you how to use these encoders. It just is going to see like how you can apply Snowpark ML for your ML operations, right? So that's one thing which I want to call it out. This is not, again, it's not an ML tutorial. This is going to say how do you apply your ML concepts using Snowflake, right? And then finally, we're going to train the model, do the inference, and predict what's going to be there. So we're going to use a very famous diamond data set, all right? So for people who are new to Snowflake, obviously, when you get your link, and then kind of like when you go back and then sign out, you'll kind of get into something like what you see on my screen. So I'm on one of the worksheets. Probably let me close the worksheet and go to home. I'm going to be on the home here. So you'll be seeing something like what you see on the screen. This is what we call a snow site. Whenever I call a snow site, it is the web console of Snowflake, which we call a snow site. Okay. Snowside gives you a lot of other stuff. Like, for example, the very important stuff that you have to note. But the moment you sign up with our trial account that we shared some time back, by default, everybody will be as an account admin. Please don't change to any other role for the quick start because we assume you will be the account admin. But it's not recommended for production though, but it's just for a trial. And later you can also play with changing your roles, seeing the permissions, etc., etc. But make sure that you'll always be on default as an account admin when you see this. To find out which role you're in, if you go to Snowflake on Snowsite, you could see the role listed just below your name, right? You'd use a name or something, okay? And for this particular lab, so we are just going to go, you can feel free to explore the other stuff which we have here, but we are going to see only two things. One is like worksheets. So we have two types of worksheet. Basically, one is your SQL worksheet. Another one is going to be your Python worksheet. When you click on this plus button, you'll see the multiple things here. You can have a SQL worksheet, allows you to run SQL commands directly against your databases. And we have a Python worksheet, which allows you to write Python code, right? And then works with this stuff as well, your UDFs and UDTFs, etc., etc. And you can also group every of your worksheets into a folder. I'm just giving an overview. People who are already familiar with Snowsite, excuse me for this. This is for people who are completely new to Snowflake, just to get familiarized with. Whenever the quick starts or anything, say, okay, create a worksheet. It just means that go to projects, worksheets, and then create a SQL worksheet. It says create a Python worksheets. Then it says, okay, go to Python worksheet and create a Python worksheet. So this is what is a quick thing about it, right? And we'll see an example of that. And then we have next one you're going to use as part of this quick start is the notebooks. So that's where it's a public preview right now. We can create a notebook or we can import the notebook from our library as well. We'll show you like from where you need to import. I upload a Python notebook from my local thing also into Snowflake and execute within Snowflake as well, right? And we are not going to see about other things like we have Streamlit dashboards and app packages. So the upcoming series is an upcoming thing. We'll talk about more about this. But for today's thing, we are going to more deal with worksheets and notebooks. Obviously, the data section of this talks to you about databases and other stuff that we already have. For example, I have a bunch of databases here. So you're just going to create one for this lab as well. And then we're just going to do this. And there's going to be an add data section. This allows you to do data ingestion into Snowflake. We're not going to see that, but I'm just giving you for a knowledge sake in case if you want to play further with our Snow side things. As I said earlier, this has a $400 credit trial that we are given to you. We can try all the enterprise features. Please feel free to explore everything. Make sure that you're on US West Oregon so that you can also try the AL, ML, and other stuff. I mean, especially the Gen AI stuff that we already have. So we have a bunch of these things. We are not going to talk about the AI ML studio. Maybe like the Fridays Gen AI, if we might do a fine-tuning demo that where I can show this AI and ML. But today we're not going to see about this. We're just going to play with notebooks for today. And monitoring gives you, as usual, the monitoring, like what queries are executed. For example, you see a lot of bunch of queries that I've executed. You can filter them and all these things. The copy history, task it. You can just please feel to explore this stuff. This Trust Center is something which we launched recently. It helps you do the other stuff as well. So we are not going to talk much on this. Again, I'm just navigating through all the options we have. And once you get to the admin section of this, you'll see all the other stuff, right? Here, cost management, we have warehouses. For example, I have one warehouse that's like, well, this is what I was talking about, Snowpark optimized. If I have time at the end of the lab, I'll walk you through this as well. Users and roles, you're not going to touch any of these things as part of today's demo. We're just going to deal only with worksheets and things, okay? I think I just gave you a very quick overview about Snowsite for people who are getting familiarized with it so that like when we talk about go to worksheet, you know where you want to go. All right. The very first thing that I want you to do is that if you are on the first page on the overview, we're going to say that there is a Git repo here. Probably we'll also put that thing on our Slack to everybody so that it's easy for you to do. Just clone this Git repo onto your local machine. And that's where you're going to import these notebooks from. I already have that inside my thing. I can obviously do an import, but just for other's sake, I'll request my support people to kind of put this link on the chat to everyone so that you know what is the right URL for you to do this. Okay. So on the first step, we're going to prepare the data first before we even go to doing this stuff. So what I'm going to do is I'm just going to copy this. As I said earlier, to get started with notebooks, it says log into Snowsite, run on an SQL worksheet. So what does it mean? So go to Snowflake. I already have one, but I'm going to create one for the demonstration sake. I'm just going to say here, and then go back to my instruction, copy this one and paste this one here. Okay. So bunch of things to explain. These are all self-explanatory. These are a bunch of SQL commands that we are going to execute. I'm using a role sysadmin. You know that I'm by default, I'm an account admin, but I'm going to use sysadmin. That's what you see here. You don't have a warehouse selected. I'll tell you what happens if you don't select a warehouse. And then I'm going to create a warehouse first, then do a database, then schema on it. And then I'm going to create a stage. Stage is nothing but a place where you hold all your assets. And if again, for people who are completely new, if you want some introduction about Snowflake, very, very basic introductory thing. So we have a Coursera course that we are linked on the resources section. You can try them to understand more about all Snowflake concepts there, right? So we're going to do this. And then finally, creating a CSV file format. This allows you to parse your CSV file and import them inside a Diamond CSV into our database, right? Diamond Assets database, right? And then we are going to list it out and do the stuff, okay? That's what I'm going to do. So I'm just going to run, I think there are multiple options. You can run all to run everything, or you can put the cursor on this line, wherever line you want to execute and press Shift Enter to get it executed. I highly recommend doing line by line because that allows you to kind of grab any errors that you might have so that like you don't miss out anything when you run a bunch together, right? But if you have season, go ahead and do run all together, right? I'm just going to create a warehouse. And obviously now this warehouse, if you see this, I created this warehouse, and this warehouse is by default becomes my default warehouse to run these commands. And again, the role that is used to run these worksheets. Again, this is a very common hiccup that you might hit when the moment you start to use Snowflake. If you're not on the right role, like sysadmin or whatever role we say on the quick start, and anywhere you'll always get the object not found, this function not found, etc., on all these errors, which means that you're not on the right role. Make sure that you are on the right role as instructed by the quick start or the guide that you're following. And where to find that role, right on your Snowside console, the one that you see on right, left, and what I'm circling right now is where a role is. Because I said use role sysadmin, I've changed the sysadmin here. And I said the moment I create a warehouse, the warehouse gets created, right? Another important thing for your context is that I need to execute in the right database. That's exactly what I'm going to do right now. Create a database called as MLHOL, which is hands-on lab stands for, and then DB, obviously by default, the public schema, which is already created the moment you create a database, becomes your default schema, right? And the moment I create a schema right now, obviously my schema also changes here. So now we have all the required context, the role, the warehouse, and then the database, the schema where you want to execute stuff, right? As I said earlier, virtual warehouse is nothing but the compute where your SQL queries gets executed by Snowflake SQL engine, right? That's what it means. I'm going to create a stage here. That's a stage I'm going to create. Create a format. Format is basically helps you to parse your CSV or JSON or Parquet files in the right way it wants to do. You can check more about that in our docs. And then I'm going to point it to an S3 URL from where I'm going to load the CSV file as part of the assets. I'm going to create this particular stage and then make sure that this particular thing gets inside this. And when I list this, it's going to list me all the, only one file right now. We have the CSV file that we already have, okay? I take a quick pause here before I go further. Just for people, if you are running through this, you can just catch up with this one, or let's just keep moving it as part of the next one. Okay, I'll just give you a few seconds pause. So just to run these things, very important. Again, I'm highlighting it. Your role, your warehouse, the database, and the schema. So these are very important when you run your SQL commands or a Python commands on the worksheets. Otherwise, even Snowsight is smart enough to tell you that you're not having the right role. I don't have a database context to execute. I don't have a warehouse to execute. So wherever these are required, so it will be obviously said, and the green dot here says that this compute is started. All the computes, all the warehouses within Snowflake are in a way you can imagine like serverless, which means that if I'm not going to use for 5 minutes, which is by default, it's going to automatically suspend. So which means that my credits are saved end of the day, okay? So this is what here, this is the context, your role, warehouse, database, schema, okay? Great. So what's next we have to do? So we have created the schema, we have created the database, we have created everything. So that's what we did here. It also gives you an overview of all these stuff that we are going to do right now. I'm going to go to the next thing and then say, okay, I'm going to start the very first notebook that I'm going to do here. So what I'm going to go back to Snowflake, projects, notebooks here. And then I'm going to import the notebook. As I said earlier, please clone the repository. You'll find the notebooks there. So if I have to go to my repository, I'm just going to go here, go to my labs. I have a Snowworks thing, and then go to quick starts, Git, Snowflake labs, and then intro into Python. Let me go find out the right one. Go here. There we go. So this is going to be my repository for this thing. Let me make it a little bit. SF guide intro Python. This is a repository that you clone. Click on the first notebook. That says SF notebook data ingestion. That's what we're going to run right now, and click open. As I said earlier, there's two things which is important. One, it checks for a database. And obviously, this again a small bug right now with our thing, which is getting fixed. The database that we created is not listed here. Okay. To do that, all you have to do is like just refresh this once you get to the notebooks. I think sometimes it get refreshed, sometimes it doesn't. But once you refresh that and do the same process again, go back and pick the first notebook and then open it again. I should see the MLHOLDB here. And then the schema is MHOL schema here. And I'm going to use a warehouse that I created here. So I have two warehouses. I'll talk about this a bit later. But for all this work, the quick start lab, we're going to use MLHOL warehouse. Okay, I'm just going to do this and then click create. All right. So this is just going to create your notebook here. It takes you a second setting up your notebook, etc., and all the stuff. And then you see this here as well. And I'm just going to slide this up to make more space here. So what we did, we went to the setup tree. We already cloned the Git repository. If you remember, the Git repository is right there here. I think we already have the link on your chat or on your resources section on your Zoom. So go there, clone the repository. On the repository, you'll find a notebook name like this, SFNB Snowflake ML Data Ingest. And that's what we have got imported into our thing, right? SFNB Snowflake ML Ingest. And then we have set up our database context and everything to run this stuff up, okay? And then if you remember, I told you about that Snowpark already has links to Anaconda and all of the stuff, which means that I can directly pick this package. For example, this says that I have to install Snowflake ML package. I'm just going to find out here. Snowflake ML Python, we already have here. And you can also pick the version you want. I'm going to go with the latest for this, and we'll show an example how to pick the version as well later. By default, you have Python and Streamlit. We are not going to use Streamlit here and then leave it here. And then you can install all these packages. And then the moment I run the first cell, which is going to be your the cell here, obviously this is a notebook one. Needs no introduction. Just run this stuff right here. It's going to run the stuff all by itself right here, right? So that's what it does. So it's starting your runtime here and then kind of starting to run your thing. It's active right now. And one change, obviously, we have to do here again. I highlighted this where we'll be using. There will be a type called as double type. I'm just going to use a decimal type here because we already have decimal into the ML library now. So we'll talk about where I'm going to use. But in case if you see a double type, it's no harm. But if you want to use a decimal type, you can also go use a decimal type as well. Okay. I've imported all the stuff. This is a standard notebook thing. We're just going to execute. The good thing about Snowflake notebooks is that very important. We can run SQL, we can run Python code as usual, and you can also use Markdown. So you can use any combination of all these things. Okay. The next one is what is very important. One, because I need to make sure that I'm on the right database, right user role. The database is MLHOLDB. Obviously, the one which you selected during the notebook is what gets listed here. And the schema is also the one which is selected during the times gets listed here, right? And version, the Snowflake version that you're going to use, and Snowpark Python version that you're going to use. So one thing I want to highlight here, in case if you're talking to community or raising a bug with Snowflake or anything, make sure that you grab these versions. You can copy these ones from these notebook things to find out which Snowflake version and which Snowpark Python version that you're going to use to raise your bug against. This is very important when you want to talk to people, community or developers about the errors that you're facing. Okay. Great. And then what next we are going to see is that, as I said earlier, Snowpark allows you to run SQL queries directly. Okay, what I'm going to do here is that I'm not going to use df.show, just want to show you something. So I'm just going to say diamonds df. So you also get your little bit of IntelliSense. And then there is a queries dict inside that. So that's I'm going to show this to you to see what basically it has, right? It's going to run this SQL. LS means listing all my diamond assets. If you remember, that's where we created a stage connected through an S3 bucket to kind of pull this diamonds.csv, okay? And then we are kind of reading the CSV inside our Snowpark API using Snowpark API kind of thing, doing a field delimiter, infer schema, parse header from this particular CSV, okay? I'm going to run this one to show you what it basically does. So if you see here, so it creates a bunch of queries here. That's what we said about Snowpark. Snowpark doesn't execute these queries. Okay, I think because if you see this one, this is just 1.4 seconds. It's impossible for me to go from Bangalore to US West and run something which is 1.4 seconds. Again, it's going to run there in the data center. But again, the time it takes to do this, you see this bunch of queries that gets created here. As I said earlier, data frame API, Snowpark data frame API is lazy, which means that it doesn't execute the query unless and until I do this show here, right? So how do I verify this? So let me stop here for a second. I'll go to my Snow site. That's where we are. And then go to the monitoring and go to the query history. When I click on this query history, to see it here. So let me do this way. You have a bunch of these things here. Go to this one, something like your monitoring thing on a query history. So when I go here, probably I don't want to do, let me duplicate this thing so that I can show you that without leaving the notebook. Okay. I'm going to go here, go to query history, and then let me put last day, and then do some filtering here, right? And then I don't have anything executed until now. Something got executed 46 milliseconds ago. These are all notebook creations. I don't have any query that basically ingests the data into it. Okay. That's exactly because I've not done show here. Okay. I'm just going to run show in a second and then show you the query that got executed to kind of do this stuff for me. Okay. Let's go here, run this query for me, and then it's going to now ingest the data inside, and the data is gone shown here from the data frame, obviously the pandas thing kind of thing. And then when I go back to my query history here and then do a refresh, and then there you see, right, all my SQL queries got executed right here, right from this thing, right after my temporary file format, blah, 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 all these things, the list of queries, if you remember that I showed you, got executed now. So this means my data frame, whatever you do, unless you do this show or describe or something like that, or run or execute, collect, there are a lot of other methods which technically needs to run the query. Your data frame doesn't execute any queries for you, right? That's what we meant by Snowpark data frames are lazy and they execute only when it's needed. Okay. So that's what we did here. I think we saw the queries here. I just put this one in case if you want, just dot queries. You can explore the method that's right there that runs a query for you. Okay. Great. So what's next we have to do? We have to see what are the columns that I have. Obviously, these are all standard data frame things that you do. I have caret, cut, color, clarity, and everything that's there. And then I'm going to do a bit of data cleansing as part of the next steps, right? One thing is that I want to make everything consistent. Just want to make all the names. If you see here, the names are all in small and everything. I just want to make a little bit more database conventions just to make sure all the names are there in capital letters. That's what I'm going to do here so that even when you write it back to a database, everything is there on the same way, right? I'm just going to do this. And then what you're doing right now is that if you see here, the cut column is kind of like it's inconsistent, right? I have spaces, I have something like small, capital, everything mixed together. So I want to clean this up a little bit. So what I'm kind of doing is there is a functions operation. Where is this F comes? If you check for the import, we have a bunch of functions that is available out of Snowpark that allows you to do a lot of data manipulations, right? Cleansing data, etc., etc. So that's what you're doing here. I'm going to go down and then kind of make sure that my column names are consistent with underscores, like typical SQL syntax, right? So that like there is no errors for me when I use these columns. That's what I'm going to do right here. Execute this stuff here. And then you see this all got into capitals with underscores, spaces removed, all special characters removed, because that's what I'm saying here. If anything which is not within this is nothing but a word boundary, right? That's what we call as a word /w regex expression that we call as, which is going to invert this, the tilt. And then I'm going to replace all those things with underscore. So you can use any format you want to make sure that that particular column value follows some typical syntax, right? SQL syntax or Python syntax, so that it's easy when you do the processing. Great. The next one, again, I'm going to check the schema. And you'll see these are the schema. Again, the schema gets inferred automatically for you from your data frame. That's again a specialty that we do with data frame. I think most of the others ones should also do. But again, we have a struct field, we have a caret color, decimal type 3,2. We are doing all these things. If you see string type, decimal type, and all of the stuff, right? That's what you're doing here. So we have done that. And then what I'm going to do is like, here I'm casting to decimal type. Actually, if you take the notebook up, I've not merged it yet just for the sake of this lab. So the decimal type is already available right now. So I'm just going to do a decimal type casting with 5,2. I think your notebook by default is double type. That's absolutely fine. You can use double as well or decimal, whichever way you want. I just thought to be consistent. I want to show you that you can also do this as well. That's the reason why I updated this code here to do this decimal update. I'm going to do an update of this column so that the precision is right there, like what we have right here. And all columns are decimal columns, right? The data types is there. And what we're going to do finally is that the data frames also gives you a write method. Write, the mode overwrite means that every time I do a write, my data within this table is going to be overwritten. Okay. Otherwise, like the data gets appended. You have to be careful with these two things. If you're not specifying mode, by default, the mode is append, which means that if I keep writing, if I'm running this SQL, this command, I mean, it's this line again and again, it's going to keep appending the data, which means that I'll have redundant data, right? That's why I'm using overwrite here, so that every time you run this, the data gets overwritten on the table. It's just like truncate and insert kind of stuff. Okay. That's what you do here. I'm all good. So if I go back here, so we will do this. And then if you go back to the query history and then do a refresh again here. This again, I'm showing for the demonstration purpose to make sure that what we have, we call create a replace table command here. And then we have all the other stuff from here, right? It gives you the exact query that you run here. Okay. Since I have a little bit blown up screen, I have to scroll down here. You'll see the exact create a replace table, blah, 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 and cast to numbers, etc., etc. Take the data from the CSV using this file and then insert it. Okay. So this creates a temporary file and all this stuff. You can find out all the queries that your thing executes, right? You can all find this one going to query history. Go find out. We'll see more about this in a second when you go to the ML stuff, where you're going to see what other things that Snowflake ML can do for you. Okay. We're done with thing. And if you also go to the databases, ML, and then you go to all schema, you should see a table here called as diamonds, which have all the data on the data preview. If you see here, I got a bunch of data inserted into this. Okay. So let me flip it back to the query history so that when I get back, it's easy for me. So we're done with the third step, kind of ingesting the data. The next one is what you're going to do is like, we're just going to do some feature transformations with the data that we got inserted, right? We're going to see pre-processing pipelines. What are the APIs that Snowflake gives you to do this? And then kind of do some transformations as well. Okay. So to do this, same step, go back again to your notebooks. Click on this notebooks here, and then you'll see, okay, I'm going to leave this notebook now. That's fine. I'm going to do import from PNB, and then I'm going to step, right? The steps are numbered like 1, 2, 3. See this here. 1 is what we did right now. 2 is the next one. 3 is the next one. And we are given some external notebooks for your reference. And Streamlit inference, we are not going to use that as part of this demonstration as well. Okay. It's going to open this second one. Same steps. Choose the database. I want to go to ML That's where my data resides. The schema, that's where my diamonds table there. I'm going to use the warehouse ML warehouse, right? Which is the default small warehouse. Okay. It's not Snowpark optimized. And then you'll see that when I actually run the stuff, right? Because it will be a little slower for us when you do that. Okay. But I'm doing that. I'm using that because like when you're using with Snowflake trial account, if you use larger ones, make sure that it's suspended as quickly as possible. I'll show you that if I have time at the end of this session, so that like your credits are not exhausted very fast. Okay. Same steps. I'm going to go back to packages. I'm going to add Snowflake ML, and then I'm going to add a couple of more libraries. So I'm going to say Snowflake ML Python. I can keep adding this. I'm going to add Seaborn for my graphs and plotting, matplot for plotting the stuff. I have all these things here. Just added these labs, matplot, Seaborn, lengthing as given in this instructions here. And then I'm going to go run this one for yes. Okay. So that will automatically start my in-ring runtime. Again, I also have a virtual warehouse and this runtime engine that's going to run for you, your Python back thing, run all your Jupyter notebooks there, right? So I have a bunch of stuff here. You can just go through this. We have a pipeline. We have, this is what I was talking to you about. Snowflake.ml.modeling. This is the package in which we have pre-processing, pipelines, metrics. We're going to see about correlation soon. And then we also have some dependencies, the NumPandas and NumPy and Pandas, Matplotlib and Seaborn and all these things. Few more stuff for us to do. I'll tell you what we are going to use this for. These are the basic Snowpark API things, right? Snowflake.snowpark is the package where you can find the APIs as well. Okay. And just ignoring some warnings here. So don't worry about that. That's all you're going to do. So I'm just going to execute again. So make sure that I import all this stuff. Again, this is again a repeat of the earlier one, making sure that I'm on the right schema, right database, and right account admin user role, right? The very first step we are doing here, diamonds table, this is where we wrote the data in the previous step, if you remember. I'm just going to get that current database and make sure that I have the table right there. Okay, that's what a table, get the current database, get the current schema. Within that, that's going to be, this is going to give you the fully qualified name. If I just do a print of this, you'll see what I mean here, right? Okay, when I run this, you see the full schema name, MLHOLDB, MLHOL schema, and diamonds, right? So just make sure that I give the fully qualified name everywhere. It's a good practice as well. And how do I load the data? I'm just going to use session.table again. So When I do this, this is what I want to show you again. So what this basically does, if you do the queries again, so this is not going to query the data again right away, right? It's just going to do a select star. So obviously these gets transpiled into your SQL queries. That's what Snowpark does for you, right? And they're not going to execute it unless and until I query for it. If you remember again, if you want to verify this, go to query history, refresh it. I don't have show or done anything done here right now. So that there's no queries executed here. If you see this, there's no select statements. Okay. Just going back again. So where this happens is that's where. So I'm going to do what in next few steps. We're going to run few of the common transformation things that we already have, right? Min-max scalar, and then we are going to use one-not encoder so that like everything we convert them into numerical data, which is required for machine learning, right? That's exactly what you're doing. These are all given out of the box. If you remember, if you go back to your imports, you'll see all those things right here. SnowML. We'll use this as SnowML dot thing so that making sure that it's coming from Snowpark ML package. Okay, that's what we're going to do. Let's scroll it down. I'm going to do this right now here. Snow ML MMS min-max scalar. So what we're going to do next few steps, we're going to run them individually for demonstration purpose. Once we are done with this, we are just going to go and put it inside a pipeline and run a pipeline for us. Okay, that's what we're going to do. So you're going to run all these things right here. And then finally, when I do show, that's where the things is going to get executed for us, right? So that's what I'm going to doing here. If we see here, I'm kind of converting this caret column into caret normalized column into this using min-max scalar. These are all nothing very specific to Snowflake, but the thing what you have done, as I said earlier, we bought these packages inside Snowpark so that you get trusted ones from Snowflake so that in case if you are having issues with these packages, you can definitely raise a support ticket to us so that we can help fixing those things for you. Okay. So again, the enterprise open source enterprise thing, right? This is exactly like how it works, even if it's the other way around. Okay. And again, we are going to use ordinal encoder for color and clarity. Again, this is for demonstration, and it also shows that you can also use pandas directly API here. This also gives you a flexibility that I can use data frame pandas APIs interchangeably as well, wherever applicable. Right. I'm just going to do this thing again. So this gets encoded. I think this is what you say, right? So I'm running a very small warehouse. That's the reason why it's going giving you this taking so many seconds for you to run. So I'm just going to keep going here. And we have done these things. You see the category, the index that is created using the one-not ordinal encoder stuff. Okay. And then we're also going to use one-not encoder for cut, color, and clarity, just to show you how this works. Again, we're going to fit and transform the data. This can be done in one shot using one-not encoder. So instead of doing multiple different steps, just showing how we can do those things directly. We have input columns and output columns, blah, 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 and then find out all these things. Okay. So this is just for demonstration to show various functions and methods that we have at Snowpark API. And the usual way we do this is using a pipeline, right? So we have the categorical columns like cut, color, and clarity. It's one-not encoder thing, what you're going to output that column name as, what are our numerical columns that we have. And then we are going to put these categories, classifying these categories again. And then finally, we are building a pipeline here, right? This is again a standard scikit-learn pipeline. That again comes within our Snowpark thing. We are bundled inside this. We are taking multiple steps. OE, that's a one-not encoder, min-max scalar, numerical columns, what you're giving this here, everything. And then the very important stuff is that we're going to dump this into a pipeline file and then store the pipeline data, right? The file that gets processed, JSON lib into our stage. So this is again advantage that you get when you use platforms like Snowflake, because we give you place where you can go store these file. The next probably the next step in the next notebook, you'll see how we put it in a registry as well, so that you can version it and get it out as quickly as you want. So I'm going to do this again. Run this pipeline. Okay, I missed something here. Sorry. And then come here and run the pipeline. The pipeline runs, and then the transform data is you're just doing it one shot. I think the earlier steps were just for demonstration, as I said, for illustration. We got all these data here, and this get dumped inside the JSON lib thing pipeline file, so that whenever we run this pipeline file, you're going to get all these data. We'll be loading this pipeline file in the next step. So this is what we got, right? So we got all the things transformed, the feature transformation. It's so simple. Like it's not going to be, there's nothing different from the standard way you do. But only thing is that within Snowpark, we're making sure that you get the enterprise quality of these libraries or APIs that you're using it. Okay. And I'm going to put it on a stage. If you remember, we created the stage. That again an advantage. I don't need to keep creating this file again and again. I'm just doing this one again. Okay, you're just going stored, it's uploaded and saved inside my thing. But I can go find it out. If you go to let's go here, databases, schema, stages, and you see this assets file, and then you should see those ones right here, right? I'll just do this enable directory stage so that you can see this ones right here. You see this one? This is a pre-processing pipeline library file that we stored here. Okay, that's last line which you put here. So you can just go find it out from go to database, data, database schema, stages, and the stage which you are pushed in. And then you can, if the directory listing is not enabled, just click on that so that you can see this values here. Okay. All right, so we're just going to do some little bit of correlation. We're going to measure the correlation here. This again, it's a standard stuff that you're going to do. The correlation function, if you remember, we imported from there earlier on, but this is going to give you a pandas data frame. Again, this is what the advantage that you get with libraries like Snowpark, API that Snowflake gives you is because you don't need to jump between multiple different formats. You can always be with data frame, API syntax, and keep doing with data frame, okay? And you see this correlation, obviously this correlation is very clear that carrot and the price are highly correlated, right? Because we see those things very high. The carrot increases, the price also increases, okay? So we're just going to do a heat map of this. So we remember we import a CBON and then we're going to get the heat map here. And then again, this 92, we can just get that. This heat map shows you that these are all, again, highly correlated one, right? The carrot and the price. We are bothered only about carrot and price here because that's what we're going to predict. So, but you can play out with other things if you want and then find those. I think I like this. There was another CMAP, if I remember correctly. Let me see if I got this name right. Okay, where it is, right? I like the color of that heat map. Yeah, that's a one, I guess. So because this gives you an even neater colors, VRIDIS. So I think you can go to Seaborn API to find this one. So this gives you even a better color heat map so that I can know this. This is even measure the price and this one is highly correlated again, right? As carrot increases, your price also increases. That's what I mean by there. Okay. That's one. And finally, what you're going to do here is that you're going to plot this one, right? Using again, this one here. I'm using the same one right here. I just put a few other things. I can just copy this one. I'm going to put this one in case people are following this because there was a update to the API. This one doesn't work, the alpha one. So you can try the other two ones which I put here. So I'm just going to put this on the chat for everyone so that like in case if you want to, you're following me, you can update those lines on your notebooks so that like it works as expected. Okay. I'm going to do this run again and then see the one is going to be a scatter plot. And then you'll see that it's exponential, right? Because the moment the carrot increases, the price increases like this again. So again, these are all standard ML stuff, but we all have everything inside this using Snowflake Notebook. We are right within Snowflake. Closer to my data and doing stuff with my data. Okay, that's the other big advantage that we get out of that. Okay. That's pretty much I have on the second one, right? I think at the interest of time, maybe I might slip 5 minutes over. Excuse me about that. We're going to go to the last step where you're going to do the actual prediction. Okay. That's what the last step talk about. Go to the last one. We're going to import the third notebook here. Go back to notebooks. I'm going to say, okay, fine, no problem. Import my notebook here. And then there we go. Choose the database. Choose your schema and the warehouse. Okay, I'm just going to do this. And we're going to do the same import of packages. I'm not going to give, I'm just going to keep doing that right away so that this is what I'm talking about. We're going to import a specific thing, right? So I'm going to say Snowpark ML Python. And then if you want to pin a version, you can just click this drop down and then go and pick the version that you want, right? In this case, and just for demonstration purpose, you're saying you use the latest, but it doesn't harm you. You can use any latest version you want. I'm going to use Seaborn again because you're going to do a plot for linear regression later. matplotlib again. So that's what they're doing. And then I'm going to go here and start my warehouse. So this is the last part of it. So where you're going to predict using our model and use model registry to store our models as well. I'm just going to demonstrate those two things as part of this one. Okay. This is again the same one, making sure everything is there, making sure I get the right table name, fully qualified table name, and going to show the data. That's what I'm going to have. So just querying the data here and then showing them whatever we have on a table. So these are most for the regression model to kind of have these column names so that like it picks up. Again, we are going to load the pipeline so that it has all the column names, categorical column, numerical columns, everything. And this is where again, right? So this is session.file. If you remember dynamic file access that we talked about Snowpark API, I'm using that to kind of load the pre-processing pipeline that we stored earlier into this one. And then I'm going to use the job lib to kind of, job library is again what we imported earlier, if you remember. Okay. And then kind of using the job lib, I'm kind of opening up, loading the model pre-processing pipeline here. So this allows you to store, and then you can version. I can store the pipeline in S3 or GCS or Azure storage, wherever you want, and do the stuff. Okay. I loaded the pipeline and I'm going to do this split, get the training data set and the test data set, everything. And the one good thing about this one is that these are all going to be UDFs, which means that user-defined functions, unstored procedures that's going to be executed on Snowflake. We'll see in a second. For example, before we execute this, let's go to our query here, right there. I'm going to query history. Just make sure just to see where we are on the query history. So we don't have any kind of a SQL create functions kind of stuff here. So I'm just going to go run the stuff here. Okay. And then we'll come back here to the query history to show you what I mean, right? So these are all, as you read through this, it allows you to create a temporary store procedure behind the scenes and run the store procedure, which is going to make it even more performant, right? Because you're going to run direct SQL queries on the data. So I'm creating a split here. Okay. That's what I said. Since I'm running on a small warehouse, it takes a bit of time. If you are flip to a bigger warehouse, it's going to make it quickly. But let's stay for a small one, considering that I don't want you to, when you try, I don't want you to exhaust your credits faster. Okay. I think obviously you need to be very cautious about those costs and other stuff. So let's go back again to the query history. I'll see is anything executed. I don't think so. I'm right here, 214. I do a select query here. There's nothing. There's a temporary table that got created for splitting the data and other stuff. Okay. We are not done anything specific to doing this one, right? Splitting of the columns. Right now, I'm going to use an XGB regressor and then kind of do a prediction, fit and predict, obviously. I'm going to train the train DF and then going to use test DF to predict it. Everything, these are all pretty much standard. If you remember, we use these categorical columns and everything we defined earlier. So that's what I said, like if you're going to use, we'll use a bigger warehouse in a second, but this is what it takes like 15, 20, 25 seconds with a small warehouse to do this stuff. And then when I go back to query history, this is where the interesting stuff happens, right? And you should see there's a temporary function, as I said, that got created. So you don't need to write a function. I already wrote a function here. Snowflake does it for you. And then let's also find out there should also be a call to a store procedure. If you see here, there is a temporary store procedure that got created here that fits your data and do all of the stuff, right? It's going to use an handler, execute stuff, etc., using XGBoost and all of the stuff. So the idea here is that I don't need to write, because when you go for ML, the very important thing is data. How do I prepare my data? How do I get my training data set? How do I get my other data sets? The rest are all, except for the tuning of parameters, rest are all boilerplate code. So why do I need to write it again and again and again? I don't need to do that. And also need to execute very fast. That's what we do with XGB regressor right there. Okay. And then if I go, yeah.
Just want to do a quick time check. We are at time, but
Yeah.
I suppose if everyone is okay with it, we can extend it by a few minutes. But yeah.
It's just to take maybe like 5 more minutes. If that's okay with everyone, I can just go finish this stuff in 5 more minutes.
Perfect. Thank you.
Okay, great. So just going to, I'll run it quickly, because since it's a quick start, you can go again, try it by yourself. I don't want to take more time. It's just, we did some kind of a prediction here. cut and color, etc., etc. Again, as you know, caret and think of highly correlated is going to increase. I can also have the MAPE got from this as well. I have these functions available out of the box from Snowpark ML API so that I don't need to write this code again. So I'm just going to compare these two things, price and predicted price, and then find out how much they are different. And it's not a bad score, 0.07, which means like, which is pretty good score here. And then I'm going to plot this. Obviously, these are all, you can use a Seaborn to kind of plot these things right away. And it's a perfect thing, right? You see here, it goes on linear regression. It's not too far, the predictions are, so which means that it's a good one. And then the other one, which you're also going to see is like, we are going to use, you know about search CV. We have a grid search CV as part of Snowpark's ML, which allows you to do this thing in a distributed way, which means that it's more performant, more faster. Okay, that's what you're talking about. If you remember, when I was giving the introduction, I was talking about that we have a grid search CV, which means that we're always Snowpark ML does in distributed way. That's what we're doing here. And then again, we're going to do this, find out what is the best estimator, building up the search CV here. That's what we're doing here again. This should take a little bit of time for us to go there and then find out a thing. So let's give some time for this because I'm running all on small warehouses. That's the reason. As I said earlier, I think this one should technically go on higher one because we are increase the warehouse size to large so that this is a little bit faster. And then let's execute. Let's wait for this to complete. I'm going to fit it again into grid search and find out what's going to be my best estimator parameters, right? That's what we're going to find out in a second. And thank you so much again for everyone for just hanging on with me for a little overtime thing. But I want to complete this with showing you the model registry, which you'll see that in a second as well. So again, as I said, don't worry if you don't follow this. You can obviously go back and try the whole stuff with this. And we have the community forum links on the chat and Snowflake intro course for you to know if you're new to Snowflake and all of the stuff to make sure that everything works fine for you, right? That's what it takes a minute and 2 seconds. And then we see all the parameters getting listed here for you. It gives you a table, list, and all other stuff for you. Let's go and reset the warehouse back to small because we don't need a bigger warehouse. Now we are going to find out the best estimator here. So this is going to be again 500 and 0.4 is the learning rate. That's what we are going to find. You can keep tuning this to find out. This thing again, since we are using grid search, CSV basically means it's distributed, right? Let's go and predict this with this one and then analyze the results. That's what I'm going to do again. We're going to see here, this is the most better performing model estimator that we're going to use. That's what you see in the graph as well. My screen is a little bigger. I'm going to see if I can scroll this here, this side. Okay. I can scroll this one, right, to see this right here. Okay. I'm just trying to find out. Okay. Sorry. Okay. I'll do that. So this is the learning rate we find out from the with the lowest map. So that's what it did. Again, we are going to use the same CSV to predict, which is going to be pretty much closer to what we predicted earlier. Let's wait for some time. And then you got the same one, 351, 353, which is not too far. And even a better one, right? 0.6, right? Earlier one was 0.7. Here we got a MAPE of 0.6. Okay. That's great. We do a plot. We should not find a big difference in the plot because it's pretty much same. It's cutting through it. But we have a lot of closer values to the predictions, right? Which means that our estimator and predictions are right. We can keep tuning these parameters to make sure which one is better. And since we give all these parameters out of the box for you, you don't need to compute those things by yourself. So you can just directly come to your predictions and model other stuff. Okay. And we're going to get this metadata out right here. And this is where the model registry comes. You don't need to do anything for model registry. It's available out of the box. There's a good Medium blog post where you're going to save the model. This will take a bit of time, a minute, close to a minute, because you're going to create this thing and then store the model inside the model registry and version it out. So that like what happens is that in future, like if you want to flip the version back up and down, like what you do for a code, it becomes super easy for you. I think we're almost done. We just have one place. Just once this is done, I think we have saved the model. We got the versions also. We got 2 versions here of the model store. If that's what we did here, model version 2, model version 1. That's a default version. That's what we have stored here. We can load the model, any model you want. Like how do you go the code, and then we have to go run a test and do a function named predict here. This is going to run a predict function, anomaly function behind the scenes, okay? And then it's going to predict the value for you. I should see the prediction there. Output feature, this is the prediction that you got, the value for the model that we have stored. We have stored V1 and got the prediction done as well, okay? This is exactly what we can even store this one on a table type, temporary table, so that it gets stored. And then you can get the price also done. Just do a query of these data again. So right now it does a diamonds.predict. If you remember, this is exactly the same one which got executed here. The same SQL function, just showing you the SQL version of it. There's a predict function that is available on the SQL variant of it. I think you should also see the prediction value here, what we got for here. Okay. That's the one here. And finally, this again, we are going to store the prediction version V1, store the data from diamond data set and see what actually happens as well. So we got the price and everything. Let's see if we got the prediction done as well. And then we can clean up the stuff. I'm just done through the last tweet a little quickly with the interest of time. I can delete the model. And then finally, there'll not be any models right now for you. It's empty. Okay. I think that's pretty much I have. And again, thank you so much for hanging on with me for extra time. I hope it was helpful. We have a lot of links on the thing, and over to you, Farhan.
Thank you so much, Kamesh. Thank you so much, everyone, for hanging on with this session. I know this was a lot to take in, specifically given that there was an intro to Snowflake ML as a part of this session. So we did cover some of those aspects. We did cover a hands-on lab where I know you all must have the link to the quick start and also to the GitHub repo. If you don't already have it, we'll share it with you very, very shortly. I know we are over time. I don't want to overextend it, but I want to extend an invitation to all of you for anyone who has any questions about this session, about Snowflake ML, about how to make things work. You can reach out to any one of us individually over LinkedIn or to our email addresses. So if it is Farhan Chaudhary, it is farhan.chaudhary@snowflake.com. Same goes for Kamesh. You'll see our first names and last names. It's simply first name dot last name at snowflake.com. So you can send out to us your individual queries. If you are stuck at any particular step, you can share with us a screenshot and we'll try to help you as quickly as we can. I know close to 700 of you joined this session. We might just take some time to respond to you, but that said, we will respond to each and every one of you. If you have any questions, any queries, reach out to us. I know we are very well over time, but once again, I would like to thank all of you for joining on the very first day of Snowflake Discover AI in India. We are continuing this streak tomorrow, day after, and the day after tomorrow as well. We will cover, again, the likes of MLOps. We'll cover data science. We'll also tell you the best of Summit. So remember, we did our flagship event where we announced a lot of features and capabilities onto the platform. We'll share a very quick glimpse of what's possible on the Snowflake platform. And if you have any questions, you can always reach out to us. We'll do more of this. There are more sessions coming up. We have Snowflake Ascent. The link is already there in the resources down below. You can see this link popping up. For those of you who want to join our local chapters in India or in the region and want to meet with us in person. So if you want to meet with Kamesh, join the chapter. If you want to meet with Anshul, with myself, with Harish and everyone else, just join the local chapter that exists closest to you. We meet quite regularly. We meet almost every other month, if I'm not wrong, Kamesh. Yeah? Yeah, so if you want to meet us, have some fun, have some good food, and talk about all things Snowflake, then you know where to go. With that, I'd like to thank all of you for joining on this session. We will see you back tomorrow once again. We have done today, that is a virtual hands-on lab. Tomorrow and day after are our virtual sessions covering all things AI. And the final day is an LLM bootcamp, which I'll highly recommend all of you to join. We'll bring back Kamesh, and we'll try to make sure that we cover all ground with AI on Snowflake. With that, thank you so much, everyone. Have a wonderful day ahead. And thank you so much, Kamesh. Thank you so much, Harish.
Thanks, everyone. Take care. Bye.
Thank you. Thank you. Bye-bye.